to see my note, right? This problem is about the piecewise function. We're going to talk about piecewise function. What is a piecewise function? A function is a piecewise function if the function has different equations in different parts in its domain. For example, this function we are looking at, f of x. This function uses different equations or mapping or programming for different input in different parts of the domain. Let's firstly find the domain for function f of x. You guys remember, we can describe a function as a machine, right? The machine produces unique output for any given input in the domain. Normally, the function has one programming or one equation determines how the output, how the machine produces output for any given input. But for piecewise function, we need more than one programming. Let's look at the function f of x here. It has three equations, right? F of x equals 0.5x plus 6 if x is less than or equal to 94. F of x equals 91 if x is bigger than 94, less than or equal to 2. F of x equals negative 0.5x plus 4 if x is bigger than 2. From this part, you can see the domain of the function is all real. Why is all real? Because those three parts put together make a real number set. The first part, x is less than or equal to 94. Let's say this is a real number 9. This is 94, this is 2. So the first part, from the infinity, from net infinity all the way to 94, including 94, right? Second part, from 94 to 2, including 2. And the third part, from 2 to past infinity. So if we put all the three parts together, we have a real number set. That's how do we know the function, the domain of the function is all real. Let me write it down. Domain of the function, sometimes we use this notation, d of f. The domain of the function is all real, is negative infinity to past infinity. In the graph of function f of x, the domain, the x values are on the x-axis, right? So we know now the domain is all real. So value of x could assume, variable x could assume any value on the real number line or the horizontal real number line, the x-axis. And now, so this is the domain, right? This is domain. So now I'm gonna divide the domain into three parts based on the piecewise function. The first part is from net infinity to 94. The first part is from net infinity to 94, left open, right close. Second part is from 94 to 2, left open, right close. The third part is from 2 to past infinity, right? Three parts. The first part, net infinity to negative 4, right here. I'm going to color, what color do I want? The pink, including the point. So this is the first part, from net infinity to negative 4, right? Horizontally, I divide the rectangular coordinate system. I'm going to divide the system into three parts. The second part is from 94 to 2. 2 is right here. Okay, 2 is right here. And what color I want? I want to maybe use yellow. This is the first time we encounter piecewise function, so I'm going to take time. I believe the colors will help. So this is the second part. The third part is from 2 to past infinity. I'm going to use blue. The color doesn't matter, just want to, as long as they're different. So from 2 to infinity, I use blue color. All right, so I divide the rectangular coordinate system into 3 parts based on the 3 sections in the domain. And piecewise function works this way. In different color, we use different mapping, use different equation to determine how the y depends on x. X is the independent variable. Y is the dependent variable. When x assume values in the pink region, when x assume values in the pink region from net infinity to -4, the y value is, so in the pink region, the y value equals half x plus 6. I read the decimal as a fraction, then we can better apply the rise and run. So the mapping, so the machine produce output when the input is in the pink region by following this equation, this mapping. And in the yellow region, when x is between -4 and 2, y equals, f of x is y, right? Y equals -1 is a constant function. Means no matter what the input, as long as the input is in the yellow region, the machine always produces the corresponding output. The output is -1. Regardless the value of the input in the yellow region, the output is always a fixed number, -1. So that's the mapping for the yellow part. And the third part, from 2 to infinity, the machine produce output by following this equation. Y equals -1 over 2x plus 4. When the input from the machine is from the blue region, then the machine follows this mapping, this programming to produce the corresponding y value. So different part of the domain use a different mapping. Okay, now let's graph it. The first, the pink region is half x plus 6 is a straight line, right? The y-intercept is 0, 6. 0, 6 is y-intercept. Slope is 1/2. Rise over run. So rise is 1, run is 2. I assume you should be pretty familiar with this type of content. So I find 0, 6 first. 0, 6 first. This is the y-intercept 0, 6, right? And from this point, I go up 1 and go to the right 2. Rise 1, run 2. So I have this point, right? This point. So I connect the 2 points. I connect the 2 points. I have this straight line, right? Do you agree, guys? However, we could only keep the part of the straight line in the pink region. We can only pick the part of the straight line in the pink region, because in the yellow and the blue region, we have a different graph. So this straight line only for the pink region. So I'm gonna use this color right here. All right. And let me see, how do I erase the black? Can I erase this way? Be very careful. Yeah, I'm gonna have to draw the yellow again in this part. Does that make sense, everybody? We draw the straight line, y equals half x for 6, but we can only keep the part of the straight line in the pink region, because that's when x is less than or equal to 4, right? Does that make sense? And now let's look at, yes? Now let's look at the yellow region. In the yellow region from -4 to 2, the mapping is -1. Any input bigger than -4, less than or equal to 2, the corresponding y value is -1, is a horizontal straight line, right? Horizontal straight line at a -1. -1 is right here. But since the interval is left open, right closed, we need to have a circle here, have a dot here. And we have a dot here, by the way. We have a dot here, but circle as the horizontal line segment. The horizontal line y equals -1 supposed to be the whole thing, right? But we only keep the part in the yellow region. We only keep the part in the yellow region. So that's the yellow part. And now let's look at the third part in the blue part. X is,
can I ask a question real fast?
yes, yeah.
Can you repeat? So the circle is for when it doesn't have the negative or positive.
Circle is open. Circle means the point is not included, is excluded. The reason we do a circle, because look at the yellow, the part of the yellow corresponding x is strictly bigger than -4 and less than or equal to +2. So at 2, yeah, 2 is included, but -4 is excluded. So we have a circle here. That's a good question. And in the blue region, the mapping is y equals -12x plus 4, right? Let's draw the straight line. The y-intercept is 0, 4. 0, 4 is right here, right? 0, 4. And slope is -1/2. When the slope is -1/2, we can write slope as -1/2. And that gives us rise is -1, run is +2. So from the y-intercept 0, 4, we go down 1 unit and then go to the right 2 units. Let's do that. Go down 1 unit, go to the right 2 units. We have this point, right? So I'm going to connect those 2 points. I'm going to draw the straight line here. It's supposed to be a straight line, but same as earlier, we only keep the part in the blue region. We can only keep the part in the blue region. So in the blue region, we draw a straight line. And at here, we have a circle, by the way. We have to have a circle there. Anybody understand why? We have to have a circle here because the third part, the third piece of the function is when x is strictly bigger than 2. So 2 is not in the blue region. 2 is in the yellow region. That's the reason the third piece has a circle. That's supposed to be a circle, okay? That's supposed to be a circle. It has a circle on the end at x equals 2. Does that make sense? Do you see it? So that's the graph of the piecewise function. It is a piecewise function, so when we graph the function, we have to graph each piece. I know it's kind of like 3 functions. Do you have any questions, everybody? Be very careful with the endpoints. Do you guys remember vertical line test? Vertical line test determines if a graph, a function, right? We're drawing the graph of this piecewise function. It is a function. So the graph has to pass the vertical line test. That means if you have a point here, if you have a pointer here, you have to have a circle here. You cannot have 2 points. If you have 2 points here, then the graph will fail the vertical line test. Same with here. If you have a circle here, okay, then you have to have a straight solid dot on the right here. You see I'm talking about, and my arrowhead, my mouse right now is white. If you have a circle here, you need to have a solid dot here. If you have a circle here, you need to have a solid dot here. You cannot have both solid dots. If you have both solid dots, and the graph will fail the vertical line test. And we will have a cheating husband, right? With 2 different wives. Any questions? I hope this is clear.
I'm sorry, could you just repeat the D of F? I just wanted to write down like a definition for that, and I don't know why I'm drawing a blank on what you said that is. The domain. Oh, okay, never mind. Sorry, I did write it down.
Yeah, D of F is a domain. You don't have to use that notation. It's the domain. The domain of the function is all real. When we draw a graph for a function, we must be clear what's the domain of the function. It is important. In a sense, domain is more important than range, because variable y depends on variable x. What really matters is the scope of the values of x. So we must be clear what's the domain. The domain is all real. So we need to make sure from negative infinity all the way to positive infinity, we have the graph, right? At -4, we have a solid dot here, we have a circle here. At the +2, we have a circle here, we have a dot here. And everything, seamlessly connect each other. It is a function. And we are not done yet with this function, okay? I hope the drawing isn't too bad. Next one. We are not done yet. Next, we are going to find out the first part of the problem is to draw the graph for the piecewise function. The second part is we need to find the output for this piecewise function when the input is -10. We need to find the value for f of -10. The meaning of this notation is the output or the y value of the piecewise function when the input or x value assume -10. So what do you think? Normally, when the function is not piecewise, there's only one equation, then you just plug in x equals -10, right? But this piecewise function has 3 equations. Which one should we plug in? Where should we plug in x equals -10? Do we plug in it? So what should we do?
The top one and the bottom one?
The top one and the bottom one, two of them. How about this? Is a -10 belong to the pink region or yellow region or blue region?
The pink region.
Yeah. -10 only belong to the pink region. -10 only belong to pink region. Well, you can tell from here. -10 fall here, right? -10 fall the first piece. -10 is no more than -4. -10 is not in the second piece, not in the third piece either. Only belong to one piece. That's the first piece. That's the pink region. Okay, since it's a pink region, then we are going to plug in this equation, right? Do you agree? So we're gonna have is 0.5 x plus 6, and we frame x. That's how I plug in. Retire x and put a -10 there. In other words, you're plugging in x equals -10 into the first equation corresponding to the pink region. All right, let's evaluate. Positive times negative, -5 plus 6 is 1, right? -5 plus 6 is 1. And my drawing is not very accurate. It's supposed to be -10 comma 1, but yeah, it's just a draft. So far so good. So far so good. That's how we find the y value for a piecewise function if the x value is given. Number 3. Number 3, f of 2. This notation represents the value of the output of the function when the input is 2. When the x value is 2, what's the corresponding y value? So 2, where is 2? Where is 2? Is 2 in yellow region? Yeah, 2 is around here. Is right here. Is 2 in the yellow region or blue region? It's on the boundary, right? But which one should we which equation should we consider?
The third one.
Look at here. X equals 2.
Greater. Less than or greater. Okay.
Yellow.
X is less
than. It's yellow, right? 2 is in the yellow, not in the blue. Do you see it? 2 is in the yellow, right here. X is strictly bigger than 94 and less than or equal to 2. Less than or equal to 2. Yeah. So 2 is in the yellow, not in the blue. Blue is all the real numbers are bigger, strictly bigger than 2. So 2 is in the yellow, not in the blue. Okay. So then we should use the yellow. We should use yellow or the second equation, which is 91. Yeah, that programming is simple. It doesn't matter the value. As long as the value in the yellow region, the output is always equal to 91. That's it. You have to find which piece. Yeah, this here is the second piece. So we use the second equation. Number 4, we're looking for f of 4. F of 4. This notation f of 4 represents the value of the y when x assumes 4, or the output of the function when the input is 4. Okay, we need since it's piecewise, we need to find out where is 4. Is 4 in the pink or yellow or blue?
Blue.
Blue, awesome, very good. Then we use the third equation, right? The third equation is negative. Let me start a new line. Negative half x plus 4. So we plug in this equation. Replace x with 4. 0.5 is half. Half of 4 is 2. And don't forget, there's a negative sign in front of it. So -2. -2 plus 4 is 2. So the y value of the piecewise function when x equals 4 is 2. We use the third piece. And this is a very good problem. I try to not rush it. We took time to understand the graph. We take time to understand the corresponding relationship between x and y for piecewise function. I'm recording the class, and you can always go back to watch this part. Do you guys have any questions? I want to make it very clear that this is a dot, here is a circle, and this is a dot, here is supposed to be a circle, okay? It's a little bit too thick, too big. Piecewise function. Any questions? All right. And let's see number 22. So number 22, we start section, I think it's section 1.5 right now. Composite function. We're going to talk about composite function, all right? Composite function involves 2 or more functions. And the notation for composite function look like this. Will you see something like that? Composite function could involve 3 or more, but as a beginner, we are going to only talk about 2 functions, all right? We are talking about a composite function involves 2 functions, let's say f and g. this notation, F circle, the circle is not O, it's a very small circles, not zero, small circle, F circle G of X. This represents a composite function. This also represents a composite function, but they are different. What's the difference between those two composite functions? For this function, G is the inside function, F is the outside function. And this one, F is the inside function, F is outside function. I want you, whenever you see some notation like this, I want you to translate it right away. I want you to translate this as F of G of X, and translate this as G of F of X. So do not worry about the notation. When you see the notation, translate them to this notation right away. Okay? And then we are going to focus on talking about composite function in that notation. Okay, you guys remember we describe a function as a machine. Then what about composite function? A composite function is an ensembling line. Ensembling line. Let's use y equals f of g of x as example. This is a composite function. So we can describe this composite function as an ensembling line with two machines in it. The thing, the x in a parentheses, is still input, okay? This is still where the input locates. So the input goes through the inside function. Inside function is G, because G is closer to the input, right? So input has to go through G first. So that's why we call G the inside function, because it's closer to the input. Input goes through G first. Yeah, so the input X go inside the machine G, all right? And it will have a output, corresponding output, which is GX. And then GX is going to go inside function F. So we call, if we have G as inside, then F is outside. So the G of X kind of like a semi-product. The semi-product is going to go inside the second machine, F. And then the final product, the output is F of G of X. Normal function, one machine. But composite function, when it has two functions involved, then it is an ensembling line with two machines. The input goes through the inside function first, and then goes through the outside function. And the final product is the output. So this is the input. And this is semi-product. We don't have to worry about that too much. And this is the output. Composite function is one function, but it's more complicated. You can see that as a ensembling line. So this is the output of the composite function. You can maybe lay this like Barbie dolls. So let's say this is the input is a Barbie doll. So we put the Barbie doll in the inside function, the first machine. The machine applies certain treatment. Let's say put a dress on the Barbie doll, right? And then the semi-product is a Barbie doll with a dress. And then the Barbie doll with a dress go inside the outside function, go into the outside function. The outside function has its mapping, programming. Let's say the programming is put a jacket on the Barbie doll. So dress inside and the jacket outside. And then the final product is a Barbie doll with a dress inside and the jacket outside. So the machine applies certain treatment. All right, does that make sense? What if we have a composite function G of f of x? Then we're gonna know the inside function is f this time. Outside function is G. So the enzyme line, the input X gonna go through F first, and then go through G. And then the final product is the output of the composite function. I think the best way to understand it is do problems. Let's look at the problems. This problem, we have two functions are given. The first function f of x equals 4x minus 7 is a linear, right? Yeah, the equation gives us the mapping, gives us how the output corresponding to the input. The input is x, the output is 4 times x minus 7. And we also have function g. Function g is x squared minus 4x plus 7 is a quadratic. So we have two different functions. We have 3 parts. Well, this is a different problem. Let me do this. Okay. So I have 3 parts for this problem, number 23. The first part, notation. Okay, do not worry about too much about the notation. It is, oh, my bad. It should have a parenthesis here. Sometimes it doesn't. Our book has the parentheses. So the first notation is F circle, little circle, G of X. Remember I said, do not waste too much effort on this notation. When you see something like that, right away, translate or rewrite the notation to a different notation. The different notation is F of G of X. Okay, is that clear, everybody? Right away, rewrite that notation as F parentheses. Inside the parentheses, we have G parentheses X. Translate that. In this composite function, the inside function is G. The outside function is F. Okay. How do we find the function? How do we know what's the composite function here? How do we compose F and G together with G inside, F outside? We have different methods, but in the class, I'm going to only introduce one method. And the method in the past, my students like better than other methods. So I'm gonna only introduce one method. The only one method is get rid of the inside function first. Get rid of the inside function first. The inside function is g of x. The g of x is given, right? G of x equals what? G of x equals x squared minus 4x plus 7. You understand this step, right? All I have done is I replace g of x with x squared minus 4x plus 7. Why could I do that? Because they are the same. They are equal. The reason I can do that because it's given that g of x is x squared minus 4x plus 7, right? So I can replace g of x with x squared minus 4x plus 7. Okay? Okay. So I can color this as yellow. So now we get rid of one function. Two functions too much. So we get rid of one already. G is gone. We only have f now. F is right here. F of x equals 4x minus 7. Okay? Let's see, how do we find the f of yellow? Let's see, how do we find the f of yellow? F of x is 4x minus 7. So f of star, when the input is star, the corresponding output is the quadruple of star minus 7, right? So when the input is yellow, it doesn't matter what the yellow represent. When the input is yellow, the corresponding output would be 4 times yellow and then minus 7, right? So that's the mapping of f. So now our yellow is this complicated expression, but don't worry about that. It's just the yellow, it's just a star. So the corresponding output after we apply function f, the result, the output will be 4 times yellow. 4 times yellow. Let's put the yellow right here. Just a copy. You don't have to worry about what's the detail. It's just a yellow, right? 4 times yellow, and then minus 7. Do you agree, guys? Do you agree, guys?
Yeah.
Okay, perfect. And then you simplify. Next step, you simplify. Let's distribute 4 times x squared, 4x squared, 4 times negative 4x, negative 16x, 4 times 7, 28, and then minus 7. And we can combine the last two constant terms, 4x squared minus 16x plus 21. There we go. That's the composite function fg of x. It is 4x squared minus 16x plus 21. That's how do we compose two functions to create a composite function. That's part 1. All right. Let's do part 2. Part 2. We need to find a G circle f of x. Again, when you see something like that, when you see the notation like that, right away rewrite the composite function in a different notation. Use the parentheses. In this case, f is inside function, g is outside function. So this composite function can be written as g parentheses f parentheses x. Right? The input goes through f inside function first, and then the semi-product f of x goes through as the input goes through outside function g. So translate that to g parentheses, yeah, we call that OF, g of f of x. Okay, same with earlier. Two functions too much, too many. Let's get rid of the inside function first. Get rid of inside function first. The inside function f is given right here. It says f of x equals 4x minus 7. So we are able to replace f of x with 4x minus 7. So inside the parentheses, f of x, we're going to write that as 4x minus 7. It's given f of x equals 4x minus 7. So here we replace f of x with 4x minus 7. And we have one function left now, g of x, right? And the pink is the input for g. Let's see how do we find the corresponding output. Let's analyze function g. Function g is quadratic. Function g is x squared minus 4x plus 7. So how does function g work? How does the machine g work? Whenever you give the machine an input, the corresponding output is a little bit more complicated than other functions. Is you square the input and then minus quadruple of the input and then plus number 7. So if your input is pink, the corresponding output would be square of pink and minus 4 times the pink and then plus 7. So we have our pink, right? You do not have to worry about the detail of the pink. It's just the input. The pink is our input for function g. It is equal to, and let's see how do we find the corresponding output. It's going to be equal to square of pink. Square of pink. Square of pink. And then minus 4 times quadruple our pink. Yeah, remember our pink is 4x minus 7. Right? And then plus number 7. G of input, the input is pink, equals square of the pink minus 4 times the pink, and then plus 7. In the next step, you can distribute, rearrange everything. I'm going to do this part quickly, all right? This is not the focus of the section. So I'm going to use the formula. This is a square of a binomial difference. Those formulas you learned from Foundation 2. I posted my videos from Foundation 2. If you have extra time, you should watch them. So I'm going to go ahead to expand this. I have 16x squared minus 56x plus 49 minus 16x plus 28 plus 7. And then we have 16x squared. Combine like terms. We have a negative 72x and 49. This is 28. This is 7. So 35, 84. Right? Yeah, I write it a little bit fast. Let me double check. 16x squared, 49 minus 28, double 28 is 56x minus 16x plus 28 plus 7. That is 7. Yeah, that is 72x. And plus 35, 4, 8. Yeah, that's correct. Yeah, this part is like algebra part. I'll leave you work on your own if you need help with figure it out. Our focus is how do we, compose the two functions to get this composite function. How do we put the two machines together to get the assembly line? Any question about number 2, part 2? Then we do part 3. Okay, part 3. Part 3, we are looking for F circle G of 7. Okay, and what's the difference of this with part 1? Part 1, the input is X. So your result is supposed to be an expression in X. But part 3, the input is a specific value. So the way we process this problem, this part number 3 is different, okay? Is easier actually, okay? So firstly, you can translate the notation as this, right? And either recommend you try this method if the input is a specific value. So the inside function is G, put it here first. Yeah, the input 7 gonna go through G first. And the outside function is F. So this is the assembly line. So the input is 7. Let's see, you're gonna help me, okay? When you give the machine G input 7, what's the corresponding output? What's gonna come out from machine G?
7G.
A G of 7, right? Or G of 7. G is here, guys. G is given. G is given. G of x equals x squared minus 4x plus 7. So when this is machine G. When the input is 7, what's the corresponding output? Can you find it?
G is 7.
G of 7? Yeah, what is the value of it? You're right, it's G of 7, but what's the value of it? Plugging in x equals 7 here. Plugging in 7 squared minus 4 times 7 plus 7. 7 squared is 49. 49 minus 28 plus 7. So we have 49 minus 28 is 21 plus 7 is 28. Yeah. Do you agree the output is 28, everybody?
Yeah.
It takes the effort. Yeah, it takes the effort. You would have to plug it in, unfortunately. Yeah, let me double check. Always double check. It never hurts double check, right? I plug in 7, 49 minus 4 times 7, which is negative 28, and then plus 7. 49 plus 7, 49 minus 28 is 21. 21 plus 7 is 28. Yeah. You see it, right, guys? For machine G, if you give the input is 7, the output is 28, is a number, is a value. We are able to find the value. So we have to figure out the number of the value of the output is 28, okay? So 28. And we see the 28 here as the semi-product in the assembly line, right? We're not done yet. And the 28 come out from machine G. Right after 28 come out from machine G, 28 gonna go inside, go into machine F. Okay, So now 28 is the input of a machine F. Okay, let's remember that. Now we are going to give machine F input 28. So our machine F is right here. Right? Machine F is right here. When you give the machine F 28, what's the output? What's the output?
105.
Okay, sounds right, but let me double check. Sounds right. So the machine F produce output equals the quadruple of the input and the -7, right? So you're plugging in. When the input is 28, you quadruple 28. You have 112 and -7. You have 105. Awesome, exactly. It is 105. 105. So you have the output 105. So the answer for part 3 is 105. Do you see it? Yeah, draw the assembly line. You would see that clearly. The input is 7, go through function G. Yeah, function G, machine G works like this. So if I plug in 7 for X, I have the output 28, right? And then 28 come out from machine G and then gonna go inside machine F. So 28 is going to be the input of machine F. When you give the machine F 28, the machine F produce an input, the corresponding input 105, 105, and that's it. Do you think you can do it? Am I clear about how do we find this? Use the assembly line?
Yeah, I understand it.
Perfect. Perfect. You guys are doing great. Very good. Yeah, we have more to practice. Next one is part 4. Okay, I think the order might be a little bit off. Use the below to find this. Okay, so the two functions are given. One way to describe a function is table. Remember, function is relation. Relation is just a collection of ordered pairs, right? Ordered pairs. So as you can see, we have a ordered pair. X is the input, f of x is the output. So the first two rows give function f. Row 1, row 3 give function g. Since we put them all together, as you can see, function f and function g have the same domain because their x values are the same, right? Okay, so that's what we have. We're gonna complete the 4 parts. Let's do the first part. Let's use the assembly line method, okay? First part, we need to find the f circle g of 2. That is f of g of 2. Okay, let's do the assembly line. Inside function g first. Outside function f after. Input for the assembly line is 2. Okay, guys, look at the function g, the last row in the table. When the input is 2, what's the output? When the input is 2, what's the output of g?
Two.
Yes, awesome. These two, right? You see that? Perfect. All right, so that's a semi-product. And that two gonna go inside function f. Okay, gonna go inside function f. So let's see function f, row 2 in the table. When the input is 2, what's the corresponding output for the machine?
-9.
Perfect, you guys great. There we go. The answer is -9. You enter -9 here. You see it? Let's do number 2. Number 2 is G circle F, -9. Okay, so this is G of F of -9. Assembly line, 2 machines. This time, inside function is F, so F first. Outside function is G, so G after. Input for the assembly line is -9. When you give the machine F, -9, So now we do machine F first, right? When you give the machine F -9, what's the output?
2.
2, very good. And now 2 is going to go inside machine G. So 2 now is the input of machine G. Machine G. What's the output?
2 again.
2, very good. This 2, right? It's different 2 here. So you get a 2. All right. Would you like to try number 3 and number 4 yourself? This part. I need to this part here. Put a it doesn't do it. Okay. You separate this. Okay. Wow. Separate. Number 3. We are looking for, oh, this one is a little different, right? FF. What does that mean? 2F? Both F and both outside and the inside function are F. Yeah, the input is 15. Yeah, do not worry about that. Just draw your assembly line. This time, the assembly line, the two machines, both are F. Both are F. Okay, so the input is 15. And you tell me what you have, all right?
It goes to -10, and then it goes in the second machine, and it goes to -2.
Give me 1 second. Let me erase those, get rid of those. Okay, so you said 15, get a -10, and then -10 get 15. Get a -2. The result is 92, right?
Yes.
Perfect. You did it right. Very good. Perfect. Since both inside and outside function are F, we only need to look at the first 2 rows. Ignore G. So when the inside function is, when the input is 15, the corresponding output is -10, right? So -10 come out from the first F. And then it's gonna go to the second machine, -10, since it's still F, so the corresponding output is 92. Awesome, very good. Last one. Well, at least I have some students to really understand how to do this now. Number 4, G, circle G, 3. This is G of 3. So this time the enzyme line has 2 machines. Both of the 2 machines are G. G, G. Okay, try. So this time you do not need to look at row 2. You only need to look at row 1 and row 3.
Is it -10 and -1?
So 3 here, -10. You got that right. And then -10 goes to G again. You might saw it. Look at it again. It's not 91, right? What is it?
It's 15, -15.
Yeah, 15. Perfect. Exactly. So 3 goes inside G. We got a -10. And -10 go inside G. We get a 15. All right, guys. I want to make sure everybody know how to compose functions. Give me some response. Everybody understand how to compose functions?
Yes,
I
thank you.
understand it.
Okay, very good. Perfect. All right. What's this one about? What's this one? Oh, this also is a compose. This is also compose. So how do you find this one? FG of 91. So the input is 91, right? So inside function is G, outside function is F, input is 91. Okay, to see if you know how to understand the graph. Function f is the graph on the left. Function g is the graph on the right. So the input for g, so we go through g first. So we go to this graph first. When x is -1, what's the corresponding y? When x is -1, what's corresponding y?
-2.
Yeah, exactly. Perfect. -2. So now -2 is going to be the input for function f, right? This is -2. What's the output? You see it's 96, right?
Right.
Yeah, very good. And I believe you can do this one as well. Understand the graph. If not, you can email me. So earlier, we understood and practiced how to compose functions to get a composite function. And now we are going to talk about how do we decompose functions. Decompose functions. Where's my problems? Decompose composite function. And let me see. Decompose function. My problem is right here. Okay, I'm gonna share a different file quickly. This is my note. Okay, let's talk about decompose function. Let's look at this problem. Find the two non-trivial functions f and g such that f and g compose with g as inside function, f as outside function, gives this function. And the other way around. It does takes a little bit of feelings about functions. How do we cultivate the feelings about functions? Is if you see this a lot, if you practice a lot, you will develop the feelings. Let's see how do we decompose this one. Decompose this one. I would say the inside function could be x minus 9. Non-trivial. X minus 9, I don't think is trivial. So f of x is the g of x, the inside function is x minus 9, right? And then the outside function is 2 over x squared. That's one way to do that. Or another way to do that is, when you decompose, you have different way to compose it. The inside function could be x minus 9 to the power fifth. That's the fifth. I'm sorry. Or if it's a fifth, I would just do the linear. X minus 9 is the inside function, and the outside function is 2 over x to the power fifth. X to the power fifth, that is a actually 2 times x to the power -5. Is a hyperbola. Yeah, how do you figure that out? Basically, you want to make the function simpler. So maybe I wish this part is just one variable. Then you can just take that part as the inside function. And then replace that part with variable x, which represent the input. The second part, we need to decompose h. And we want the outside function to be x to the power 4th, and we need to find the inside function. This one is pretty straightforward. The inside function has to be the linear x plus 8. You see that?
Yeah, I understand it.
Yeah. Why do we need to learn decompose function? Because when you learn calculus, you need to decompose. A lot of times you have to take the derivative of the composite function. You have to decompose the function and then use the chain rule to take the derivative. That's why it is pretty important. And for example, if we have function y equals x plus 8 to the power 4, right? When you take the derivative, this is not convenient. So you let t equals x plus 8. Then you have a y equals, if t equals x plus 8, you have t to the power 4th. And t equals x plus 8. Basically, you bring in the third variable as the median. So y depends on t depends on x. So this is the inside function, this is the outside function. But since by convention, we use y as the dependent variable, x was the independent variable, we write this as y equals x to the power 4th, and write this as y equals x plus 8. And that's it. Our class is finished at 10:50, right? Okay. Do you guys want to do some practice on let me double check our syllabus. Our syllabus for pre-cal. Today is 28th. Let's see if we are on the track. 28, 1.5. Yeah, 1.5 I think is a composite function. Let's go to Lumen. Let me share. The browser. So today we schedule to cover 1.5. 1.5 is composite function. Yeah, we can practice more here if you'd like. We don't have to start 1.6.
I actually have a question on the syllabus.
Yes, please.
Since I'm a Norman High student, I'm gonna do my test in Norman High, and I'm gonna send an email to my principal and counselor and whatnot. On the syllabus, it says Unit 1 test review. Is that when I should say I need to do the test? Or what day should I say that I have to do the test?
You will have a week. I will give you a time window, about a week. You can take your test any time during the week. I'm pretty flexible on that. So you want to talk with your principal or counselor, you guys tell me when's a good time.
Okay, when will that first week be for that first test?
I'm sorry, the first week?
Well, what will be the time frame? Like, I know it's gonna be a week, but when will that be?
Don't rush. I will work on that. I will post it in the announcement. I will let you know.
Okay, thank you.
Yeah, we're not done yet. We just in 1.5. The first section, the first unit has 8 sections. We still have 3 sections. Transformation is kind of complicated. Inversion is not easy to understand either. Yeah, circle is easy. Circle this part, there's not much to do. So we still have like a shy half of the chapter. I will post the announcement once I'm ready. All right.
Okay, awesome. Thank you.
Let's practice more about composite. So would you like to try this one? F of x is 1 over x minus 3. G of x is 3x plus 8. What is F circle G of 7? This ensemble line has input function or inside machine. Yeah, inside function G, right? So machine G first and then machine F after. So what do you think? Yeah, let's work together.
So do you just fill in the 7 for each
Yeah.
one? Okay.
Yeah. So let's put a 7 here for G. That gives us 29, right? 3 times 7, 21. 21 plus 8, 29. And then we put the 29. We let the 29 go through function F. What do you have?
1/26.
Awesome. 1 over 26. Perfect. Good job. Very good. You see that?
So it basically just means you do the F and then the G. You put that into, okay, gotcha. Okay.
You do the G first. I'm sorry, you do G first and then do F. You do G first. I'm sorry, you do G first because G is the inside function. So I plug in,
Okay.
yeah,
Mhm.
I plug in 7 in G first. You do G, do inside function first. You put a 7 here. 3 times 7 is 21. 21 plus 8 is 29. And then that number gonna go inside machine F because F is outside function. So 20, you put a 29 here. 29 minus 3 is 26, so 1 over 26, right? What about the second part? F circle G of x. Inside function G, outside function F. Yeah, anybody would like to share this? Yeah, give you a little time.
Do you put 126 into G or X? Or 126?
Oh, we don't use this anymore. This 1 over 26 is the output of the composite function when the input is 7.
Sorry, yes. Okay, sorry. Yeah.
Now we're gonna do this one. F circle G of x.
So g of x is 3x plus 8, and you're going to put that into f of x.
Yes, very good. And what do you have as the final result?
3x plus 8 minus 3, all under 1.
3x. Oh, it's not capital F. Huh? Why is it capital? Oh, little
It'll be
x.
3x plus 5 if you simplify.
Perfect. Do you guys have the same thing? Do you need me to write this in detail? Explain this in detail?
The second one just.
Yeah, let's do that.
Oh,
Let's do that.
sorry, I'm just missing it
Don't
just
worry
by like.
don't worry about that. I need to hide the floating meeting control because it's blocking. Okay, so let's do this problem together. Okay. So we are looking for F circle G of x. And it's F of G of x, right? So we want to get rid of one function because 2 is too many. We want to get rid of the inside function first. I didn't mention there are multiple different methods to process this type of problem, but I only gonna introduce one. So the method is get rid of inside function first. The inside function g of x is 3x plus 8. You do need to go through those process, those steps. You need to have what I wrote here on your scratch paper. Try not to do it in your head. It's a very bad habit. And now we have f of 3x plus 8, right? And we can see this as the input, pink. Let's see what's the corresponding output when the input is pink. The function f of x is 1 over x minus 3. So when the input is pink, the output is 1 over pink minus 3, right? So let's see. So now our input is pink.
Are we still supposed to be looking at the lumen, or are we looking at your notes? Sorry.
Yeah, this is the problem that our Zoom meeting, it does not like automatically transition to another thing. I have to stop share this one and share the other one. Okay, my bad. I get used to the ultra collaboration in Blackboard, but this class I have no option to get that, so we have to use Zoom. I apologize. So f circle g of x is f parentheses g parentheses of x, right? Two functions too many. So we want to get rid of one function. We always get rid of the inside function. G of x is given. G of x is 3x plus 8. So replace g of x with 3x plus 8. And now we only need to handle f. And after we get rid of g, we now only need to handle f. How does the machine f work? When the input is pink, the output is 1 over pink minus 3, right? Yeah, just remember that's the mapping of machine f. Now that's how machine f work. So the output will be 1 over, in the denominator, we have pink minus 3, right? When the input is pink, the corresponding output is 1 over pink minus 3. And what is our pink? Our pink is 3x plus 8. And then you simplify in the next step. Numerator is 1. 3x plus 8 minus 3 is 3x plus 5. Right? And the other part, f circle g of 7, when the input is a specific value, we have a different way to process the problem. When the input is x, use this method. Get rid of the inside function and then work on the outside function. But if the input is a specific number, we want you to use the ensemble line, drawing the machine. Inside function is g, so machine g first. Outside function is f, so machine f after. We give machine g 7. Let's see. When you give machine g 7, this is machine g. G of x equals 3x plus 8. When you give machine g 7, the corresponding output machine g produce is 3 times 7 plus 8, right? 3 times 7 is 21. 21 plus 8 is 29. So your semi-product is 29. And then you let 29 go inside function f. How does function f work? Function f is 1 over x minus 3. So the machine f, when you give the input 29, the output would be 1 over 29 minus 3, which is 1 over 26. Is that understandable?
That makes sense. Yes, thank you.
No problem. And this actually is a challenging topic. It is a challenging topic, but please try apply the method I try to sell to you. I know there are other methods. I know if you look, there are different ways to process the same problem. But since you are taking my class, I really think the method I use is a very good one. So please give it a try. And then practice over and over, and you will like the method. When the input is numbers, a specific value, try to use the ensemble line. Then you will see through the structure. You understand, you see clearly, oh, this is the composite function, the structure of the composite function. And if the input is just x, then get rid of the inside function first, and then work on the outside function. All right, guys. We have 3 more minutes. Do you have any questions that I can answer?
No, I think I'll just.
Okay. If not, we can stop here. And today is Chinese New Year Eve, so I have some program to watch. Thank you guys for coming. I'll see you on Thursday. All right.
Thank
Happy
you.
See you
Chinese,
Thursday.
Thank you.
Happy Chinese New Year,
Thank
Timmy.
you.
Happy Chinese New Year to you.
Thank you.
Thank you. Bye bye.
Bye.